This video is on Integrated 2, Chapter 12, D-Day number 1. So in this situation, Ron, Michelle, and Tina all want to be on the prom decorating committee. The class advisor must choose 4 out of the 10 people that signed up to be on the committee. Okay, so there are we're going to choose 4 out of 10 people. Okay, choose 4 out of 10 people. Okay, just get this to be that type of highlighting. So for this, how many different 4-person committees are possible? Show all your work. Okay, so if it's a 4-person committee, order is not important, so it is going to be a combination. So this is going to end up being 10 choose 4, which is, when I work out 10 choose 4, 210. So 210 different 4-person committees. What is the probability that Ron, Michelle, and Tina are all on the committee? So the key word here is probability. And we want 3 people to be on the committee, which means that really we're going to be picking one other person. So we basically want all the ways we can pick one other person out of the 10, knowing that 3 have been picked already. So really that's going to leave us with 7 people to pick from. So that's going to be 7 choose 1 or 7 over 10 choose 4. So this is going to be 7 over 210, which is going to be 1 over 30, if you want to keep it as a fraction. So on number 2, out of 36 RBV students selected, 20, so let me just kind of highlight as I'm going. Okay, so we have 36 RBV students selected. 20 are 16 years old. 10 are 17 years old. 5 are 18 years old. And 1 is 15 years old. Okay, now what we're trying to do is we are trying to get a 4-person. So we're trying to get a 4-person. If 4 people are chosen randomly for a committee, find the probability that. Okay. So in this situation, we want to find the probability that 3 students are 17 and 1 student is 16. So first off, let's see all possible outcomes. So all possible outcomes are going to be 36 choose 4 and 36 choose 4 is equal to 58,904. So that's all possible 4-person committees, okay, with choosing from 36 people. Now that's going to be our denominator. So it says 3 students are 17 and 1 student is 16. So 17, there are 10 17-year-olds. So there are 10 and we're going to choose 3 times. And we want 1 16-year-old, and there are 20 16-year-olds. So that's going to be times 20 choose 1, which is going to be 20 different ways we can get 1 person. All over again, the total, which is 36 choose 4. And 10 choose 3 times 20 choose 1, which is really just 20, is going to be 2,400 over 58,904. And if I work that out, That ends up giving me 0.0407 about. So that would be, in terms of percent, about 4.07%. You don't need to change it to a percent, but that's what it is in terms of a percent. Now, on the next situation, each student is a different age. So really what's going to happen is, again, our denominator is going to be 36 choose 4. We want one 16-year-old, so that would be 20 choose 1, which really, again, is just 20. There are 10 17-year-olds, we're going to choose 1. So 10 choose 1, again, that is 10. 5 18-year-olds, so that's going to be 5 choose 1, which is a 5. And there is one 15-year-old, so that's 1 choose 1, which really is just a 1. So when I work that out, I really have 20 times 10 times 5 times 1, which is going to be 1,000 over 58,904. And when I put that into my calculator and do that math, I end up with about 0.01697. So let's say 70. So that would be 1.7% chance of that happening. Okay, on number 3. So on 3, Emily's little sister had 6 Barbies, Barbie dolls. Skipper, Ken, Tootie, Todd, George, and Margaret. One day she decided to play with 3 of her Barbies. Okay, so she has 6 total. She's choosing to play with 3. How many different choices does she have? Order is not going to matter for this. She's just playing with 3 of them. So that's going to be 6 choose 3. And if I put 6 choose 3 in my calculator, that is going to be 20 for that answer. On letter B, she liked all of her Barbies, but one day she decided she had to have favorites, a first, a second, a third, and a fourth. And how many ways could she choose her top 4? So if we're choosing top 4, a couple ways you could do it. You could do 6P4, because that's what a permutation is. Order matters. You could also do 1, 2, 3, 4 decision chart with 6 and then 5 and then 4 and then 3. And all of these are really the same as 6 factorial over the ones that we're missing, which is 2 factorial. So any of these is going to give us the final answer when I put it into my calculator of 360 different ways. Number 4. So how many different arrangements of the letters in the word trapezoid are there? Show your work. So first thing to pay attention to, we need to count the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. Then we need to double check and see if we have any duplicates. I do not notice any duplicates here. So in this case, this answer is going to be 9 factorial or 9P9, which is the same. And that is going to be 362,880 when I put that into my calculator. Now on number 5, find the volume of a sphere with a radius of 6. So remember when we were doing volumes and we were doing a cylinder versus a cone versus a sphere. So when I was dealing with a cylinder, I would take the area of the base, which is pi r squared. I would times it by the height, and that would be my cylinder. If I divided it by 3, that was my cone. But if I took 2/3 of it, that ended up being my volume. Now, when we're dealing with this, the height of the sphere, okay, is really our radius, sorry, our our diameter. So I'm just gonna real quick just grab a sphere shape. Let's see, do they have a sphere that's just, let's see. Okay, so here's a sphere. So if I add in the sphere, okay, so a couple ways you can think about this problem. Again, you can find the area of the cylinder, which is pi r squared times h, times it by 2/3. But this height is really the distance from here to here, which is really your diameter, or 2r. So I can really think of this as 2 pi r squared times 2r, which is really going to be 4 pi r to the third over 3. That's another formula. So you could use any of these formulas to figure this out, whichever one you can personally remember. Okay, so for this, if my radius is 6, okay, let's say I was thinking of it as the cylinder situation. So if my radius was 6 and I was dealing with the cylinder, my area of my circle would be 36 pi, okay, times my height. My height is going to be really the diameter. So that is going to be 12. And then I could times this by 2/3, or I can use the formula 4 pi times my radius cubed over 3. Both of these are going to give me the same answer. So when I take 2 times 36 times 12, I end up with 864 pi over 3. Over here, when I go 4 times 6 to the third, I also get 864 pi over 3. And when I divide by 3 in either situation, my final answer is going to be 288 pi. And these were centimeters, so centimeters cubed. That is going to be my final answer. On number 6, we want to find the area of the circle. And over here, this is not the length of the segment, it's the arc length is what they want. So to find the area, okay, let me just zoom in here. So in this case, since this is a diameter, that means that this angle right here is going to be 90 degrees, because this is an inscribed angle inscribed in a semicircle, okay, forming a 180-degree arc right here. So that angle is going to be half of that, okay? So that's the first thing. Now, also, this angle right here, the measure of this, let's say, arc measure, is the rest of this 180 degrees, 50 of it being used. So if 50 of it's being used, that means that that is going to be 130 degrees. which means that this angle here is going to be half of 130 degrees, which is going to be 65 degrees. And so this is going to be, let me just kind of take this away here. So this is going to be 65 degrees. And this angle over here is going to be half of this, which is 50 degrees. So half of 50, this one right here is going to be 25 degrees. Okay, so that's kind of what's going on in this triangle. Now, I need to figure out that green diameter. Okay, so I can figure out my area of my circle. So what I'm going to do is I can either do it from the 25 degrees or the 65 degrees, either one. Let's say I do it from the 25 degrees. Okay, if I do it from the 25 degrees. And I want to find basically the length of Vx. So what I'm going to do is I am going to have adjacent, because the 6 is right here. Okay, that is our 6. And so that is 6. And I want to find the length of Vx. So if I'm using my 25 degrees, let's say, I am going to do cosine of 25 degrees is equal to 6 over, I'm just going to call this Vx, the length of Vx, okay? So the length of Vx is going to equal 6 divided by cosine of 25 degrees. And so when I take 6 divided by the cosine of 25 degrees, I end up with 6 point, let's say 6.2 for that length. Okay, that is my diameter. Now I need the radius, so the radius is going to be half of that, so that's going to be 3.31. So I'm going to be using that 3.31. So let me move this so I can get over to this side. Okay, so the area of my circle is going to be pi r squared. And my radius is 3.31. And so when I do that, 3.31 squared, I get 10.9561 pi, or if I actually work it out using pi, I end up with about 34 point, let's say, 0.42, and this is going to be centimeters squared, and that's going to be our answer. Now, on the next one, they want the length, the arc length of YV. So that arc length is going to be part of the circumference. Okay, so I'm going to have 130 out of 360 times my circumference. And circumference is going to be 2 pi r, or basically pi times diameter. So I am going to be using this 6.62. So it's going to be 6.62 pi is going to be my circumference. And when I put that into my calculator, I am going to get a 7.51 about centimeters. Okay, this again is approximation. Now, on the next page, on number 7, what is the area and the perimeter of this. So for the area, I need to find this height, okay? And that height is going to be the same as this right here. So I'm also going to need to find this length. I know that this is going to be 20, so this is also going to be 20. I need to find basically the pink and I need to find the orange. And I'm going to be using that 32 degrees. So let's say I'm going to find the orange. For the orange, if I'm going from the 32 degrees, I want to use cosine. So I'm going to do cosine of 32 degrees is equal to, let me just call this x. So x over 17. So I'm going to have 17 times cosine of 32 is equal to x. When I put that into my calculator and I do 17 cosine of 32, I end up with 14.42. So this is going to be about 14.42 is what that's going to equal. So let me come over here and put in my 14.42. Now I also need to find my pink. Okay, so to find my pink, and let's call that H for height. Okay, it's the same one here. I am going to this time do sine of 32 degrees is equal to H over 17. So that's going to be 17 sine of 32 degrees is equal to H. And 17 sine of 32 is 9 point, let's say about a 0.1, because it's 0.08. So about a 0.1 is going to be our height. So let me come back and put here that this is going to be 9.01, 9.01. So at this point, I have enough information to figure out both my area and my perimeter. So for my area, okay, the area of a trapezoid is equal to base 1 plus base 2, that's that sum, times the height divided by 2. So I am going to have 20, let's say, is my base 1. My bottom is the 20 and the 14.42, which is going to be a 34.42. My height is going to be a 9.01 divided by 2. So I am going to put this into my calculator. And when I do put that into my calculator, the quantity 20 plus 34.42 times 9.01 divided by 2, I get 245.16 about, and this is inches, so this is going to be square inches. That is my area. Now for my perimeter, I'm going to be adding up all the way around. And so when I'm adding up all the way around, let me take this piece. That piece is not going to be added, but this piece here does need to be added. That is 17. Okay. So now when I'm finding my perimeter, I'm going to be adding up all the way around. So I'm going to have 20 plus 17 plus 34.42 plus 9.01. So 20 plus 17 plus 34.42 plus 9.01. I end up getting about an 80.43 inches. Now on number 8, a string extends from the top of a tree to a point 10 feet from the base of the tree. Okay. So I'm just gonna fancy this up a little. So let's say that I have a tree. Let's say I choose this tree. Okay. So let's say I've got a tree. And I know that for this tree, a string extends from the top of the tree to a point 10 feet from the base. Okay. So we are going to go 10 feet from the base. So if this is the base, okay, I am going to go out 10 feet. I want to figure out the height of this tree. And it's going to come like this. And we know that the string is going to be 30 feet long. And the tree base is 10 feet away from where the string is attached. Okay. And we want to figure out how tall the tree is. So I want to figure out basically this height right here, and I'll call that H. Okay. So in this case, I actually can just use Pythagorean theorem. I don't need to use any trig at all. So I am going to do 10 squared plus H squared is equal to 30 squared. So I'm basically going to have H squared is equal to, and I'm going to have basically 900 minus 100 when I do that math. So I am going to end up getting an 800. I am going to take the square root of 800. And when I take the square root of 800, which if I want to keep it exact, okay, the square root of 800 has a 100 in it. So that would be a 10 root 8, but it also has a 4 in it that can come out. And so that would be a 20 root 2. You can leave it like that if you want to keep it exact, or I can put in the square root of 800 in my calculator, and the square root of 800 is equal to about 28.28 feet. Okay. So that is our answer. And that's probably a more realistic answer that we can size it versus the 20 times root 2. Okay. So the next one, on this one, what I wanted you to do, I kind of gave you the same graph 3 times. So in this first one, this is the actual graph of f of x, okay? On the next one, what I want us to do is, with that graph of f of x shown there, I want us to graph f of x minus 1. Now, what that does is it basically is going to take 1 away from, or it's going to drop the graph 1, is what I should say. So we're going to have a point down here. We're going to have a point here. We're going to have a point here. And we're going to have a point here. It drops each of them down 1. And then I'm going to connect it. So it's the same graph, just basically translated down 1. On the next one, again, I have the same f of x graph here, but this time it's f of x minus 1. And so what does that x minus 1 do? Okay, well, what that does is basically it's going to shift our graph. And it's going to shift our graph. You ask yourself, what would get that to be a 0, a 1? So it's going to shift everything to the right one. So what's going to happen for this one, everything's going to be shifted to the right one. And then that is going to be our graph. Same graph, just shifted to the right one. On number 10. So on this one, we want to calculate the measure of x, which is this angle right here. Okay. And again, that was a degree. I'll just change it so it's made a little more transparent. Okay. And we also want to find angle y, and angle y is right here. Okay. So in this instance, okay, first off, if I know that this angle right here, this inscribed angle is 31, then I know that this intercepted arc is going to be double that. So this is going to be 62. Let me zoom in a little bit and write a little smaller. Okay. So this is going to be 62 degrees for that. Now, if that's 62 degrees, that means that the orange is going to be 180 minus 62 degrees. And 180 minus 62 degrees is going to give me 118 degrees. So I'm going to get, for my angle, my arc measure of my arc there, it's going to be 118 degrees. Now I'm trying to find angle, the angle at y. Okay, to find that angle, I am going to just kind of get rid of this right here for a second. And what I'm going to do is I'm going to draw in, maybe with a highlight, that this angle, oops, let me get this type of a highlight, that this angle is coming and it's intercepting this circle, forming two arcs. The two arcs that it's forming is this arc right here and this arc right here. So when you have basically an angle or two secants, basically, right, well, a secant and a tangent, I guess we have. But if you have two lines, okay, like we do here, from outside of your circle, what you can do is you can take the two arc measures that are formed. If this was from inside, I would add them, divide by 2. When it's outside, I subtract them and divide by 2. And when I do, I end up getting 28 degrees, and that's that answer. So again, when you are looking for an angle outside versus an angle inside, the two arcs that are formed when those line segments cross it, if it's inside, you add them and divide by 2. But if it's outside, you subtract them and divide by 2. On number 11, in this situation, we know that we have a couple of tangents here. So we have a tangent, AC's tangent. So this point right here, what that's going to do is it's going to form 90 degrees with that line segment and that radius. Over here at B, this is also going to be a point of tangency. And so this is also going to form 90 degrees with that line and that radius. We know that the measure of angle AXB and let's see, AXB so let me just so I'm just going to draw that in. I'll draw that in pink. So okay, so AXB. So what's happening is if that angle is 210 degrees, okay, I think that might have been, let's see, AXB is 210 degrees. I think they wanted that not to be an angle because that's going to make that angle way too big. I think they wanted it to be an arc. So this should be measure of arc, AXB. So if this arc, AXB, is 210 degrees, then this side over here is going to be the rest of that 360 degrees. And so the rest of that 360 degrees is going to be 150 degrees. So this, let me just write it here, is going to be 150 degrees, which means that this angle is also going to be 150 degrees. And then what I'm going to do is I am going to draw a line from here to here, cutting this in half, okay? And so when I cut 150 in half, I am going to get a 75 and a 75. So now I am going to put in my radius, and my radius is this OA. So OA is 8. So from here to here is going to be 8, but that also means from here to here is going to be 8. And we want to find the length of BC. So the length I'm looking for, I'm going to darken it. I'll do it in orange. This is the length I want to find right there. Okay, so let's just call that X. That's what I'm trying to find. So if I'm trying to find that, I am going to use trig. So I basically have a right triangle. And my right triangle, I have this side, I have this side, and I have this side, okay? And let me just draw in, this is where my right angle is. I know that this is 8. I'm trying to find this. I know that this is 75 degrees. I'm going to use trig. And I have tangent. So I'm going to do tangent of 75 degrees is equal to opposite over adjacent. So I'm going to have 8 tangent of 75 degrees. And when I put that in, 8 tangent of 75, I end up with 29 point about, let's say 856, so about 86. And they did not give us any units, so 29.86. On the next one, number 12, okay. For this one, we're trying to find the volume of a triangular prism. So when we are dealing with the triangular base prism, you're going to find the area of the base. And so the base is this triangle right here. So we're going to find the area of that triangle. And then we are going to times it by the height which is this 7 here, okay? So in this case, I have a right triangle and I need to find this value right here. Now, some of us might recognize this as a 5, 12, 13 right triangle. Let me just call this x and let's just work this out if you did not realize that. So this would be x squared plus 12 squared equals 13 squared. So I have x squared equals 169 minus 144, which is going to be a 25. So when I take the square root, I am going to get 5. So this length right here is going to be 5. So when I'm trying to find the volume, I am going to find the area of the base times the height. Now the area of the base, it is a triangle. So I am going to take my base and height 5 and 12, divide it by 2, and then I'm going to times it by the height of the prism, which is 7. So when I do that, half of 12 is 6, 6 times 5 is 30, 30 times 7, I am going to get 210 meters cubed as my answer, okay? Now I'm going to unbox it so we can read the problem below. On letter B, we have a square-based pyramid. And so when we have a square-based pyramid, we want to find the area of the base, times that by the height. And so the area of my base times the height. And then that would be if this had been a prism. Then we're going to times it by a third or divide it by 3. Now, in this case, my base area, I know. That's kind of my easy part of this. I need to find this height. I know that this lateral face has a height, a slant height of 5 here. I also know that going from here to here is going to be half of that distance, which is going to be a 3. So using Pythagorean, this is going to be a 3, 4, 5 right triangle. So my height is going to be 5. So the area of my base is going to be 36. The height of this is going to be 4. I need to divide it by 3. So I basically have 12 times 4, which is 48, and this is going to be centimeters cubed. And that is going to be our answer. On number 13, we're going to graph this and find these pieces. So what I would personally do for this, a couple ways to do this, okay? Number one, maybe you want to find your x-intercepts first. That's one way to go about doing that. Well, and actually probably I would find my y-intercept first. Your y-intercept is going to be your c. So this is going to be 0, 12. That's probably the easiest thing to find, okay? And then it's going to change the transparency so we kind of see through it. Okay, then if I want to find the x-intercepts, what I can do is put 0 in for my y, and I get negative x squared plus 4x plus 12. I don't like to solve my x for being a negative, so bring everything to this side or multiply everything by a negative. Either will end up with the same result. And then we're going to factor this. What multiplies to a negative 12 and adds to a negative 4? That's going to be an x minus 6 and an x plus 2. So I'm going to have an x-intercept at 6 and an x-intercept at negative 2. So I'm going to have 6, 0 and negative 2, 0. Now, if I have these x-intercepts, I can take these x-intercepts and average them, which is going to give me 4 divided by 2, or 2. And so this is going to be 2, something. Now, to figure out the something, okay, I am going to take this and substitute it into the equation. So it's a negative 2 squared. Now it's not a -2 in parentheses. It's a -2 squared plus 4 times 2 plus 12. So that's going to be a -4 plus 8, which happens to be 4, plus 12. I'm going to end up with a 16. So this is going to be 2 comma 16. Another way to do that, in order to find your vertex, you can use the formula -b/2a to find the x coordinate of your vertex. And so that would have been a -4/2 times a -1. -4/2 gives me 2, which is the same thing here. And then I go about the same method. You can do it either way. Now they want us to graph this. So I'm going to use these points that we have here. So let me just move this. Okay, so I'm going to plot my vertex, which is at 2 comma 16. Okay, so 2 comma 16 is right here. Now from here, I do know I had a y-intercept at 12, which means I also have the same on the other side. I do know I have x-intercepts at 6 and -2, so -2 and 6. But I also can, knowing that my equation again was -x squared plus 4x plus 12. This is an open down parabola with just a stretch of a -1. So if I know the stretch of a parabola, I can go over 1, 1 squared is 1, times that by a negative, I'd have points here. Out to 2 squared is 4, times it by a negative, -1, 2, 3, 4. Out 1, 2, 3, 3 squared is 9. This is going to be a -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And the same on the other side. And then if I went out 4, 1, 2, 3, 4, I'm going to go 4 squared 16. I'm going to go down 16, which would give me the 2 x-intercepts. Okay, so that's one way to kind of go about doing it. And then if you wanted to continue, you could. The next one would have been 25. If I went out 5, so 16. So 17, 18, 19, 20, 21, 22, 23, 24, 25, and so forth. And let me just kind of change my transparency for this so that when I draw it, we can see those points. And there's my graph. My next one would have been 36 away, which would have been down at -20 if I wanted to plot that. And that's the end of this video.